Significance of architecture in container image. Container images are packed software that has libraries, tools, and source code runtime within it. You can run the container images in machines, but there is a catch here. The architecture of the container image and the architecture of the machine in which you are planning to run the container image should match. Every machine will have a CPU. CPU will have processor architectures. There are different processor architecture like AMD 64. There are different flavors in ARM. You can find the list of architectures in this link. Container images are built for specific architectures. If we check this image, you can see that container image is built for these architectures. If the container image is only built for AMD 64, then you will just see AMD 64 here. But they have built these container images to support different architectures. That's why you can see these many options here. In production, the container image built for AMD 64 ARC must be used on an AMD 64 processor only. You can run a container image built with AMD 64 ARC on an ARM processor with the help of emulator. Let me show you that. If you go to settings, I have installed Docker. If you go to settings, here you can find an emulator. I have enabled it. In this case, I can run an AMD 64 image in my ARM processor. My processor is ARM. I am using Apple M2 Pro chip. Let's try out a quick demo. In this script, I have not specified any architecture. Even in this build command, I have not specified any architecture. Let's run this and see what is the architecture of the container image that gets generated. The image is built. Let's inspect this image. The architecture of this image is ARM 64. When you run the docker build command, by default it uses the architecture of the machine and builds the container image with it. That's why the architecture is ARM. But if I want to build an AMD 64 container image, then I have to pass another parameter called platform. So let me run this command and verify the architecture of this image. I will use this build command. This build command has platform in it. Let me inspect this. The architecture is AMD 64. When I use this platform parameter and pass AMD 64 to it, the image that gets generated is of architecture AMD 64. So in case if you are planning to create some images in your machine, make sure in which environment you are planning to deploy that container image. Most probably we will be using AMD 64 type processors only in our production environment. So it's safe to have this flag in our script. What I usually follow is I will have this platform value in my script, and I will also have the platform value in my docker build command. But you don't have to add this platform value in both the places. You just need to add it in either the script or in the build command. But I usually add it in both the places. And I will add pull no cache, which will pull the image by default whenever you run the build command, and it will not use the cached layers that was stored during the previous build command. So I usually use this format to build the images, and then I will push it to my container registry. Let's see what happens when we run an container image that is built for ARM architecture in an AMD 64 machine. I will push the ARM image to the Docker registry. I have created a new EC2 instance in AWS. It's of type AMD64. Let me pull the Docker image. Let me run it. You can see the warning message which says that the image that is getting executed is of type ARM64, but the host platform is of type AMD64. Let me try to execute the image which I built using AMD64 platform parameter. Let me push that image. I have pushed that image. Let me change the tag name and run it. It's pulling the image and the container got created successfully. So far we have learned the significance of architecture in container image creation process. If you want to create container images that supports multiple architectures, then you can take a look at this multi-platform images page and learn more about it. Creating container image which supports one platform will be sufficient for our day-to-day activities.